So hi everyone, welcome back to my YouTube channel, and today I'm up with the next video of the top 150 interview questions of LeetCode. So let's get started with the question. So the today's question is product of array except self. So we are given an integer array nums and we have to return an answer array such that answer of I is equal to product of all elements of nums except nums of I, and the product of any prefix or suffix of nums is guaranteed to fit in 32-bit integer. It means that our answers will always be between 10 raised to minus of 10 raised to power 9, 10 raised to power minus 9 to 10 raised to power 9, right? And we must write an algorithm that runs in off and time without using any division operation. Okay, fair enough. So let's get started with the question. So we are already given that we have to find the product of an array except product of array except the self. So what does it mean? Suppose I have this array. I have 3, 0, 2, 1 and 4, and now let's find out the product of this array. The total product of this array comes out to be 0, and now let's divide each and every. So now let's obtain what is the answer at 0th index. It is 0. 0 divided by 0. Oh gosh, we can't really proceed with this method when we have such a thing. Okay, fair enough. 0 divided by 2, 0 divided by 3, and 0 divided by 1, 0 divided by 4. That's what we would be actually doing in order to fetch our output array. But do you think that this will actually work for it? No, because it will throw an exception of division by 0, right? So we can't really proceed with this naive approach, like finding the product of all elements at once and then just simply dividing each element present at each index in order to obtain the answer. So this naive approach doesn't work over here. Okay, so now let's move to some other approach, right? So what we can do, in order to do this, see, we can use two for loops, right? 3, 0, 2, 1 and 4. What I can do, I can simply find out the products except this. So it turns out to be 0. I can use two for loops, one iterating from from 1 to n, and other nested within it with j iterating from 1 to n, 0 to n, 0 to n, and in this, whenever my I is equal to j, I'll simply continue, right? And in this way I'll be able to find the products of all the elements, right, except self. So I got my output using the two nested loops, and the time complexity of using two nested loops turns out to be O of n square, and the space complexity turns out to be O of 1. See, this solution is good in terms of space complexity, but in terms of time complexity it's not. So we have to think of something else rather than this, and the interviewer will also be not happy with this. So we have tried upon all the brute force methods till now. So now let's move to some better approach. So I think the better solution to actually find out the product of all the elements is, rather we can use something like dynamic programming in order to solve this question. Like, why I'm thinking of using a dynamic programming? The reason being that at some point or the other we are like, see, if I already know that what is the product till this point, like if we know the products up till here, like up till index number 1, what are the possible products that we have, we can actually, it will help us to simplify our work, right? Our work would have been simplified at this point of time, and it would be easy enough to find out what is the, like if we are storing the result up till here, then we can find out the next result using the previous result, right? That's what the point is. So I think a better solution to approach this is we can take two arrays, left and right. Left will store the products of all of these elements, and my right will store the product of all of these elements. Like, and what is the final in both? What is the final output in both of these? It would be the maximum product of the array. It means the product of all the numbers. Either we move from left or either we move from right. So let's get started. So let's initialize our first element to 1 and 1. 1, 0, 1, 2, 3, 4. Okay. So what would be this answer at till this point? It would have been, like, I am storing the previous results over here. So what is 1 into 3? 3. And 0 into 3, 0. 2 into 0, 0. 1 into 0, 0. Fair enough. Okay, and now storing the right elements. 0 into 4, 4 into 1, 4. 1 into 4, 4. 4 into 2, 8. And 8 into 0, 0. And then afterwards I have to store my answers in some another array. So what I can do, I can simply take the product of both of these left and right. So it comes out to be 0, 24, 0, 0 and 0. So I think using the prefix product and the suffix product, using something like prefix sum or suffix sum technique, prefix arrays and suffix arrays, we are able to find out the answer. And the time complexity for this approach would have been O of n, and the space complexity would have been O of n plus n, which is O of 2n, or in simpler terms O of n, because we are taking two arrays, two different arrays to store my left product and my right product, right? So this solution seems to be a better one than the O of n square and O of n. But now let's try to optimize this solution in O of 1 time. Okay, so now let's move further. So what I can do if I want to optimize my solution in O of 1. Okay, so now let's discuss the optimal approach for this solution, for this question. So suppose I am given an input array, right? I have these many values, 2, 1 and 4. Okay, so what I'm thinking of doing is, like, I have to take one answer array in order to return all the answers. So what I will do, I will simply modify my output array every time in order to get the product of each element except the self. So let's get started. So what I will assume that my first element in my answer of I to be 1. Okay, now as you've already seen that what I've done in my left array, I have basically taken my first variable to be 1, and that's what I have also done, and I will simply store the previous product in the next place. So what I will store at answer of 1, I will be storing at answer of 1, answer of 0 into nums of I minus 1 into nums of 0. So what I'm basically, so the basic formula with which I came up is that my answer of I would be answer of I minus 1 into nums of I minus 1. Okay, fair enough, because I am storing my previous results in the current. So 1 into 3, it turns out to be 3. And talking about the next, so what is this? It's 0 into 3, it turns out to be 0. So for the next place, for fourth place, it's 2 into 0, which turns out to be again 0. And now talking about the final place where I have to store the previous product, it's about 1 into 0. And what this product actually holds for me is the product of all the elements behind it. So what I'm using the previous products, I'm storing it at one place and then using it in the next part, right? So in this way I've got my products, I've got all the product of elements till this point, right? And now I will store this product in my fourth index. Fair enough. So now what I actually need at this index is the product of this and this is the product of all the I minus 1 element, 1 to I minus 1 element, n minus 1 element, it's n minus 2 elements that are present before this element, right? So fair enough. So now let's move on how to find these products, like the products from the backward direction, from the right direction. So instead of taking any right array, what I have thought is I'll simply take a variable right initialized to 1, and then what I will actually do, I will basically store in my answer of I the product of right into answer of I. I'll basically multiply this with the right. Why so? Because whenever I'm moving, because in my right portion I'm storing the product of all the elements that are coming along my right? Oh, I think it got confused. So basically what I'm storing all the products which are from my n minus 1th position till 0th, or we can say maybe from n minus 1 till so no, it's n minus 1 till 0th position only, right? So it's still n minus 1 till 0th position. So that's why I took a variable right rather than taking an array of right. So now let's compute the product of this. So what is my answer? It's 0 into 1. I'll take some another marker. So now let's compute this answer. Okay, so now what would be the answer for this? It would be 0 into 1, which is equal to 0. So 0 is my final value which would be present at this array. And now let's update my right. So what would be my right variable? So right would have been 4 into 1, which is equal to 4, because what I'm storing in right is the product of all the elements that are coming along my way from right to left. That's what I was storing in my right array. So instead of storing that result in an array, I have preferred to store it in a variable. Fair enough. So now let's move forward. So what would be my answer for this? It would be 0 into 4, because I am multiplying it with right, so it would be 0. Fair enough. And what would be the value of my right? Value of the right, I am writing it in the green. It's again 4 into 1, because I am multiplying this element with my right, and it's again equal to 4. Fair enough. Let's move further. Find out the value of this. It's again 0 into 4, because value of my right is 4. It turns out to be 0. And now calculating the value of right, it's 4 into 2, and basically I'm multiplying my right with this. So my right is equal to right into norms of I. So it would turn out to be 8. So let's compute the value which should be there at this index. So it turns out to be 8 into 3, which is equal to 24. I think it's good and fair enough to know. And this is the final value that I'll be having. And now let's compute the value of right at this point. It would have been 8 into 0, which is equal to 0, because the value at this index is 0. Now let's compute the value for the ultimate index, which we actually need. So what would be the value? It is 0 into 1, which is equal to 0. And now let's compute the value of right. It would have been 0 into 3, which is equal to 0 because the value present at first index is 0. So in this way I am able to compute my final output in O of 1 space, right? Since I only took an extra variable right and I'm keep on updating it, so I think there is no point in taking any space complexity. So it turns out to be O of 1, and my time complexity as usual it is in O of n time. So now let's discuss the code for the same. So as already discussed, I took an output array in which I am initializing the first value to 1 and then computing all the previous results in the current one. Basically I am storing all the previous results in the current, and then I am initializing my right to 1 and I am computing all the results that are coming along my right, and then I am returning the output. So let's run this solution. Great. And now let's submit it. Well done. We have got a good solution at this point. So I hope guys that if you have understood this question, please do like and subscribe my channel and share it with your friends. And one more, what I could say, if you want to connect with me on topics other than DSA, please do connect with me only on the platforms that I mentioned in the description. I'll not be entertaining queries on platforms other than that.